Alright, so today we're going to be talking about solving absolute value equations. So let's talk about what an absolute value is. An absolute value is one's distance from zero, okay? So just to explain what I mean by that, okay? If we have 0 on the number line, the distance from 0 to -5 and the distance from 0 to 5 are the same distance from each other. So absolute value is about measuring distance, not about measuring like a calculation in the same way you would for anything else. So that's why the absolute value of -5 and 5 are the same, okay? One's distance from 0. And then another vocabulary word you need to know are extraneous solutions. An extraneous solution is basically when you go to solve an equation, and when you go to solve that equation, the answer does not come out to an answer that you can plug back into the equation that works, okay? So it basically is rejected as it doesn't work out in the end. All right, so we'll talk about how we can evaluate those. So the first example we're going to look at is A. So the very first thing you want to do when you're given an absolute value equation is you want to first check and make sure the absolute value is as much by itself on the side of the equal sign as possible. There's nothing else I can bring over to the other side, which is the case here. Next thing you want to check is the absolute value equal to a positive number? Yes. If it is not equal to a positive number, you can say right off the bat that the solution is, there is no possible solution. It's an empty set because there's no way you can take the absolute value of something and get a negative number, right? So that's why we can reject it automatically right off the bat before doing any algebra. So in this case, we've confirmed that it's equal to a positive number, so this is the procedure we use to evaluate. The first thing we do is we rewrite the equation without the absolute value bar. So if in some cases you're going to need to replace these with parentheses, but in this one we don't need to. And then you're also going to write the same equation, but you're going to negate one side of that equation. You can pick either side, it does not matter. But if you happen to choose the other side, that means you have to distribute that negative onto both terms. Does that make sense? So it would be -2x minus 3 equals 5. But either way you pick, it doesn't matter. Just pick only one and one only. Do not pick both, or that brings you back to what we started with. So we're going to solve both of these separate equations. And then over here. So I got two answers. I have 1 and -4. Okay? So now we need to plug both of these each individually back into the equation. Okay? So for the first one, if we go ahead and plug that in, what is, we want to verify that it's true. What is 2 times 1? What's 2 plus 3? What's the absolute value of 5? So both sides equal each other. That one is correct. Now the other one, what's 2 times -4? What's -8 plus 3? What's the absolute value of -5? This one's good. So you can write the solutions in the form of a solution set with the squiggly brackets. No, it doesn't matter which one you write first. I just like to write it lowest to highest, personally. But that's it. Okay, let's go ahead and try the next one. Before you start separating into two separate equations, the first thing you want to do is you want to get the absolute value by itself if possible, which it is here. What can I do to get that absolute value by itself? Good. I subtract 8 on both sides, and I'm left with the absolute value of 4b plus 1 is equal to -8. Is it possible for an absolute value to be equal to a negative number? No, so there is no solution. And the way we write no solution, sometimes you'll see as an empty set. Okay, it's a set that's literally empty. Don't put 0 in there. 0 is a different thing. 0 can be a solution. So empty set. You'll also see people write something like this, either one. Or they might just simply say no solution. But those are really the ways that you see it written when there's no solution to something. Okay? I would try to be familiar with all three because SAT, they can throw anything at you. All right. So the next one, the absolute value bar is as isolated as possible, as you can see, but we can't visually identify if it's equal to a negative or positive because there's a variable involved. So we're ready to proceed to the next step. The next step is to rewrite the equation as is, or replace the absolute value with parentheses if needed. And then the other thing you need to do is you're you're going to write it by making one side negative. So it doesn't matter which side you choose, you'll get the same answer. If anybody wants to test out making the other side negative to test it out, feel free to do that. So I pick one side and I make it negative. Since there were multiple terms on that side, I need to make both of those terms negative and distribute that negative sign. So I'm going to distribute the negative. I get negative b minus 5 is equal to 2b plus 3. And now I just want to solve this equation as you would. So I'm going to add b to both sides. That's going to give me negative 5 equals 3b plus 3. And then I want to proceed by subtracting 3 over. That's going to give me 3b equals negative 8, which means b is equal to negative 8 over 3. Alright, so now we're going to go ahead and solve this one as well. So you solve it however you like to solve equations. Multiple ways to go about it. I got b equals 2. Now, we're not done because we have to verify that both of these solutions actually satisfy the original equation. So you actually are going to have to plug these back in. Now, you can do it mentally, you can do it on the calculator, you can do it by hand, but it's really important that one way or another that you verify both of these solutions. So in this one is easy. We can plug in the 2. What's 2 plus 5? What's the absolute value of 7? What's 2 times 2? What's 4 plus 3? So this one's good. This one's a little bit harder to plug in, right? So in this one, to plug that in, I'm going to put it in the calculator instead, okay? So in the calculator, you all have one. I want you to do negative 8 divided by 3 and add 5 to that. Tell me what you get. 2 point what?
2.3.
Okay, so the absolute value of that is the same. And we're going to see if that's equal to, now we're going to plug it in over here. What's negative 8 divided by 3? Do that in the calculator. Times 2 plus 3. Tell me what you get.
Negative 2.3 over 2.3.
Okay, so do these two sides equal each other?
Yes.
No, one's negative, one's positive. So this one is actually rejected, and we call this what?
Extraneous solution.
Extraneous. Very good. That means that our solution is just 2. So do you see why it's important that we check our work? Because if you wouldn't have checked, you would have just thought both of these were solutions, right? You ready to try another one?
How'd you check?
Just plug it back into this one right here. Okay. Now this one here, as you can see, it has a lot going on. So the very first thing I'm going to do is I'm going to rewrite it without the absolute value bars. But in this case, see how I have to replace the absolute value bars with parentheses because of that indicated multiplication. Okay, that's the first version. Now the second version is a little tricky on this one, and you have to be really careful about it. You have to negate one side completely. So, when I negate one side, I literally have to do negative 1 times 6 times 6 plus 1 minus 15 equals negative 9 parenthesis x minus 2 plus 15. Okay? So, over here, we're going to distribute. We get 6x minus 12 minus 15 equals negative 9x plus 18 plus 15. And then we're just going to simplify by combining like terms. We're going to add 9x to both sides. That gives me 15x equals, I add 27 over, I get 60. So x equals 4. Now we're going to do the other one. Notice I made that negative out front. So here's how I'm going to do it. I'm going to distribute inside the parentheses first. And then, did I change anything about the right side of the equation? No, so I already know it's going to come out to be this, right? So I don't need to do all that work all over again. If you want to, you can, but that side's going to come out to be that. Now I can combine like terms inside the parentheses. And then I can distribute the negative. Like so. Now I can solve. Subtract. X equals 2. So, we get two versions of this, okay? Now, we want to plug both of these back in, but it's going to take us a while to do that, so let me show you a little trick. Let's just kind of do it mentally. What's 4 minus 2?
2.
Absolute value of 2?
2.
2 times 6.
12.
12 minus 15.
Negative 3.
Okay. 4 minus 2.
2.
Absolute value of 2. Not, times negative 9. What's negative 18 plus 15?
Positive 3.
Negative 3. So does this one check out? Yes. Now, the other one, on the other hand, doesn't check out as easily. So, what's 2 minus 2?
0.
Good. 0 times anything is 0
0.
minus 15?
Negative 18.
Okay. Over here, 0 minus 2.
2
I'm sorry, 2 minus 2 is 0. 0 times negative 9 is 0. 0 plus 15 is?
15.
Does this one work out?
No.
It's extraneous. So our only solution is 4. Bless you. All right, you ready to proceed? Okay. All right, guys, don't you want to finish this up?
Yes.
All right, I need you to be quiet then. So, first thing you need to do is you want to get the absolute value by itself. So, we're going to start by subtracting 8 on both sides. That's going to give me negative 24 is equal to negative 12 times the absolute value of k over 5. I'm then going to divide by negative 2. I get the absolute value of k over 5 is equal to 2. Okay. Now, I'm at the point where I can rewrite it both ways. Negative and a positive version. I multiply both sides by 5, and I get k equals 10. And if I do the same thing over here, I get k equals negative 10. And if you plug these both into this absolute value equation right here, do they check out? Yes, so our two answers are negative 10 and 10. Is everyone good with that?
I got it. I don't know. I just got lost.
Well, this one was just quick. Guys, I can't answer a question if you're all going to talk, and if we're going to do that continually, you'll get a seating chart. And now I all know where you want to sit, so I'll give you a spot that you don't like. All right, continue. What were you saying? Who had a question?
Well,
Yes, go ahead.
so why is it a function if they don't match up? Like one's negative and one's positive?
No, if you plug in -10, what's -10 divided by 5?
-2.
What's the absolute value of -2?
2. Oh, okay. Sorry.
That's okay. Any questions? Alright, so this is like one of the most common equations that people mess up. Okay, that absolute value with the fraction in it, with the denominator. So make sure you multiply, not divide. Alright, last problem we're going to do is this tennis racket problem. So it says here, a standard adult tennis racket has 100 square inch head plus or minus 20 square inches. Write an absolute value equation to determine the least and greatest possible sizes for the head of the adult tennis racket. So, the cool thing about absolute value is it tells us one's distance from 0, but we can actually affect that by causing it to tell one's distance from a certain value. So right now, we're looking at one's distance from what value instead of 0? 100. And we're okay with it having a 20-inch distance from 100. So you can probably figure out the answers in your head. It's going to be -20 and +20, right? But to set up an equation that models that, t, the tennis racket length, if we take that amount and we subtract 100 from it, we take the absolute value of it, it should be equal to 20. Okay, that's the equation that would represent that. So, how would we go about solving this absolute value equation? We solve the positive version, and we also have to solve the negative version. There you go. So this one comes out to be t equals 120, and this one comes out to be t equals 80, right? Any questions about that? Alright, so the least number of squares is 80, and the most is 120. Any questions about that?